Hi everyone. So if you are joining us from the last video, then you're probably looking at a screen much like this one because you just finished setting up your encryption keys using GPT tools for Mac. If you have done that step previously with GPT tools and you just want to get back to this, all you have to do is go to the Spotlight and put in GPG and the keychain access will pop up, and then you'll get a screen that looks much like this. So in order to send and receive encrypted and signed emails at this point, and for a couple of reasons, you actually need to run a program. You need to run a program on your computer, directly on your computer. So basically, what we are looking at here is something that we call end-to-end encryption, which basically means that literally only yourself and or the recipient can read the email exchange. When you send something. In fact, when you encrypt an email to someone else, they are the only person who can read it, and when someone else encrypts an email that they send to you, then you're the only one who can read it, and because you have the correct key stored on that physical computer, and that's part of how it works. And you want to. That's a good thing because it basically means that there's nowhere on the internet that an unencrypted version of that email exists, which would of course defeat the whole purpose, right? Because that means that somebody else has access to it, and probably that person can be subpoenaed for it. Or legal mechanisms can be used to get access to the contents. So in order for this to work, we actually need to have a program that accesses, say, like in this case, a Gmail account, right? So this Gmail, I'm going to configure Apple Mail, which interfaces nicely with this GPG tools and lets us sign and encrypt and decrypt emails nicely, pretty seamlessly. So I haven't actually configured Mail to work with this account yet. And actually, in order for it to work with this account, you're going to need to just check a couple of settings and possibly update a couple of settings on the Gmail account in question. And so the first thing you're going to want to do is come to the settings tab, the main settings tab, and say, make sure that under forwarding, POP, and IMAP, you see this IMAP is enabled. Okay, so if it's on disable, click it over to enable. Make sure to save your changes at the bottom. And then the second thing you're going to need to do is, while you're signed in, go to this Less Secure Apps link. So google.com settings/security/less secure apps, all one word. And you want to make sure that you enable that. I guess Google considers Mail, it's entirely possible that it uses a less secure way to connect to Gmail, and their default is tighter security than that, but you will want to make sure that you enable that. Click done, and you should be good to go. So back here, I'm going to go ahead and put in the email address in question, and looks like we are in business. Fantastic. Okay, so now I have this connected to an account, and the way that I'm going to do this most simply is I'm going to start by sending an encrypted email to myself, which is a good way to practice when you haven't done this a lot, and make sure that everything is working properly. I would also say that you probably want to, it's always a good idea also to get a buddy with these things. So if you're going through this process, do it with a friend, and then you guys can get used to doing this stuff together. And actually, one point I would make about this, I actually really like using clients on my computer for a variety of reasons. It actually also has some. Just downloading your email and deleting it from a web server has, from like your cloud Gmail account, actually has some privacy benefits of its own. But I like it also because it means that I can write emails on my laptop when I don't have an internet connection. So if I'm on a train, for example, or it's just spotty or not very good, I can write emails and just have them send whenever I get a connection again, which is handy. The other thing I really like actually is that they do keyboard shortcuts really well. So I'm going to do an Apple A here, and click on the thing, do an Apple A, and hit the delete button, and boom, all those junk emails are deleted, which is a lot faster than clicking on 13 little checkboxes. So we're now at the point where we actually want to send a signed and an encrypted message. So just to again sort of reiterate the fact that these two things can be done separately, right? So we have this ability to send a signed message to anyone because it isn't encrypted, right? It isn't encrypted, but it does have that. Our digital identity, that kind of unforgeable digital identity attached to it, which means that it can be used to confirm that an email really came from us, right? So anybody can receive it, anybody can read it, but it's a way for your recipient, your correspondent, to know that it really came from you. So we're going to start with that, and actually this whole process is very seamless. So basically I'm just going to say, I'm going to put in the email address. I'm going to put in my own email address in this case because that way I can test right away that it's working as I expect. And you can see my options here. The interface to yours might look a little bit different, but basically I'm just going to go ahead and say this is signed, right, and hit send. And the first time it's going to prompt me for my passphrase. You can just click save it in Keychain, and then you won't get prompted for it anymore. Right, so, whoops. There we go. And that lovely whooshing sound tells us that everything went well. And of course, here is my email showing up in my inbox. And so we can see that the visual priority of message versus key is perhaps not ideal in this case. Great big chunk of signature kind of right up against the bottom of the message, and not so much with the message. But you know, I've not. You know, this I could, for example, if I were to go to my Gmail account, which might be a nice thing to do. So if I actually go to the web interface, you will be able to see that this is readable, right? So I can actually look at my inbox as well, right? I got an email. So this is readable in Gmail, okay? So again, I'm doing this, I'm saying this definitely came from me, and someone who received it, somebody who does have a similar setup, right, either with Apple Mail or with Thunderbird or something else, will have a way to verify this. So just to point out, right, when we say we've generated a public-private key pair, we generate keys, right? There's this idea that it's like a lock and a key that fit together, right? So essentially, the public key is the lockbox. If somebody wants to send something to me, they need that public key to wrap up the message in. And then when I receive it, I can unlock it with the key. The verification is basically this bit of text, right, is kind of like a mold of the key. It isn't of the secret key, of the private key of the person who sent the message. And basically what I'm able to do is, because I have their public key, I can use this text to see if this text fits together with their public key. That's a way to think of it. And if this text fits together properly with the public key of the person that I think sent this message, in this case, the person who's associated with this email address, then when I click verify, it's going to say, yes, this email address was definitely sent by the person with this public key. And it turns out that I did really send this email to myself. Shocking, right? Okay, so now I can verify it all over the place. So now I'm going to do another message, and I'm going to encrypt this one. So again, we can see sort of what happens with this. So I'm going to send it to myself once again. It's actually interesting. I'm not sure. I'm going to leave it encrypted. Yes, so you can encrypt something without signing it. So you can sign an email without encrypting it. You can encrypt an email without signing it, or you can sign and encrypt it. So reasons why, so we'll get to the third case now, but for now we'll go encrypted and signed. So basically I am sending this to myself, I'm sending this to somebody, and I'm both protecting the content and giving them a means to check that it really came from me. So this should be unreadable on the web. Okay, so that's going to be my test, and you can see it's stored my key. And let's see how we do. So, okay, so this email is encrypted. Now you'll see when I look at this, gobbledygook. right? Hit decrypt. Again, I could have saved that passphrase. Ta-da! Okay, so we see how that gobbledygook turned out. Let's go to Gmail and see what it looks like in Gmail. And what you'll see is it's all gobbledygooked, right? So basically, there is, and it also, you can see because I both signed and encrypted it that it shows both. It says both that it was signed by me, and we can see that that was junk as far as Gmail was concerned. So we're using Gmail as a conduit here, right? We can use its paths to send the message, but we don't have to make it readable on the web. Now, the last case is one that is, probably pretty unlikely for most of us, but it's possible, for example, that you might want to send a communication. This is more of a journalist thing, right? You want to send a communication to a journalist, but you don't want them to know who you are. Well, chances are they're going to know there's going to be a way to trace that communication back to you via your email address, but you might decide that for whatever reason you don't want to have that verification on there. For example, anybody who doesn't have your public key is not going to be able to verify the email. But it's just to say that you have all the options, so you can do both. Not a lot of use cases, I think, for unsigned encrypted emails, but I'd have to think about that. So this is encrypted and unsigned. So let's just see what that looks like. So I'm going to unsign it. And send. And so when I open this up, again, I'm going to get junk. And you see this says this has been encrypted but not signed. Its authenticity cannot be proven. I would say proven. Anyhow, so basically what you can see is that you have all combination of those cases. But importantly, again, the bit that's on Gmail doesn't look like anything, right? Nobody else could read this. And that's really what we're after here, is we want to be able to protect that content. You can see that when you set up something like Apple Mail, it's quite seamless, actually. You don't really have to think about it. Now, the one thing that this does depend on, again, is that in order for you to send an email to someone that is encrypted, they need to go through this process, so tell your friends, and also that you need to get their public key from them. And there are a bunch of different ways to do this. If you watched the first video, you saw this publishing to a key server thing. And using a key server is probably the easiest way. There's something now out there called Keybase.io, which allows for that. And also a lot of universities have key servers where you can post your key. You could certainly do it on the GNU key server. And then you need to tell people where to find it. Now, ideally, you always want to do this in person, just to make sure that somebody isn't pretending to be you. I mean, like, this is my public key. You can send encrypted emails to me, and then it's actually someone else, right? So, in that case, where to find the public key, you can send it to them, you can give it to them in person. If you have something like Keybase is relying on the fact that people kind of claim their Twitter handles and have exclusive access to them, and using that as a way to kind of hopefully make sure that the person who points to that key is actually the person people think it is. But anyhow, to point out that the process itself is actually quite simple, and in fact, for most of us, because we tend to see people that we want to exchange encrypted emails with at some point in person, actually pointing them to our public key isn't very difficult either. So anyhow, hopefully this has been useful. We're going to do some additional ones with setting up on things like Thunderbird, and again, if you have questions or comments, we'd love to see them, or requests for future topics. So that is all for encrypting email with GPT tools. Cheers.